So thanks everyone for joining us this evening for Data for Good meetup. We're really looking forward to Cam Raynor's presentation on using analytic techniques for survey data. My name is Jeff Sakave. I'm the Calgary chapter lead for Data for Good. And before we step into the presentation, just a bit of background on Data for Good for those that might be new. So we're a group of volunteers that use our technical and data skills for social good. And really our aim is to help nonprofit and social organizations that are doing amazing work in the community that tend to have a lot of data. We really want to help them leverage their data to really improve their impact. So we do analytics and visualizations and other work with the nonprofit organizations. So we're part of a national not-for-profit organization, 9 chapters stretching all the way from Vancouver to the Maritimes. We've been around since 2013. Well over 2,000 members now, and growing. And we're organized through Meetup. You can let us know and share that with your friends. We have our Twitter handle there at Data for Good YYC, and the national website at dataforgood.ca. So we do a number of things. So we have these monthly meetups. Bring in speakers on variety of topics, tend to be on the 4th Thursday of the month, which we're at now, and so look for that. Maybe put a reminder in your calendar, and you'll get notified once you join the meetup group. You'll get notified of our events as they get posted. We have a number of projects that are in flight. Such as the Alberta Law Foundation, Canadian Cultural Mosaic. We're actually working with Cam on the Canadian Social Harmony Index. You'll hear a bit more about that, and other projects as well. So in the chat, I posted a link to our volunteer form. So if you want to get involved in our future projects, just fill out that form and you'll get notified as these projects come up. And we usually have 3 or 4 going at one time. We also do our larger events we call datathons, once or twice a year. Over the years, we've worked with some amazing Calgary organizations, and of course this year we could not do face-to-face, and so we're contemplating virtual datathon with our partner this year, which is the Calgary Homeless Foundation. So we're thinking late May, early June for a kind of a virtual mini datathon. And then we're hoping by November of this year, we'll be able to gather together and have our traditional Friday night, all day Saturday, Sunday morning datathon at that point. So that's the kind of background that I want to share with you. If you have any questions, just ping me through the Meetup site or any of the others that are involved, and happy to answer your questions, whatever they may be. So we are really excited to learn a lot more about survey data. We often will come across survey data and the typical polls that we see, and I think we just kind of step into it in maybe not a very cohesive way with generating as much insight out of survey data as maybe we could. So we welcome Cam Raynor to join us this evening to tell us a lot more about that. And so Cam, I invite you to share your screen, introduce yourself, and if you have questions as we're going along, please put the questions and comments into the into the chat. So welcome, Cam.
Yeah, I'm excited to be here. Thanks a ton for having me, Jeff. Maybe I'll just share my screen here and jump into it. Okay.
That's good.
1 second. Okay. Yeah, so for today, I'm going to be talking about techniques for analyzing survey data. So in this presentation, I'll talk a little bit about some of the considerations about survey data that are different than, say, other sources of data, and what you can be thinking about. And then quite practically, we'll show some examples of some of these techniques just implemented in R for those of you who are R users. For those of you who aren't, you can sort of try to parse through it as much as you want at that point, but hopefully that's sort of a practical takeaway as well, sort of mixed in with this bit higher level discussion about what some of the things you should be thinking about when you maybe come across a data set that was from a survey or thinking about doing your own surveys. So just a little bit about me. So I'm the founder and principal of a local Calgary-based consulting firm called RA2, and we mostly work in the public engagement, political space, doing data analysis and digital tools for NGOs, political groups, and brands. Our work typically involves some combination of survey research. We do some natural language processing and machine learning work, social network analysis. And our company is really interested in this empathy-based approach to these sorts of problems. And particularly, we're very motivated from the outset when my business partner and I founded the company about how we could use some of these data tools to reduce political polarization in particular, and do a better job of communicating with the public. So we've worked on a range of campaigns for both locally here in Alberta, but also all over the world, sort of in Australia. We do a fair amount of work in the UK. We've been recently working with a group in Uganda. So it's been a sort of varied experience. And a lot of our work, because of the public engagement piece, involves working with survey data. So it's something that we encounter sort of almost every day. So at a very high level with the survey data, we're generally trying to infer something about opinions, attitudes, beliefs, etc., about a large group of people. So the whole population, as we'd call it, from a sample or a small number of people that actually answer the survey. So this is the biggest difference, of course, with survey data, is that you don't have all of the data and you're trying to make some conclusions about a group of about data that you can't actually observe based on some smaller portion of it. And there are a lot of considerations that go into this. So the framework that we use is called the Total Survey Error Framework. And this really recognizes that survey error comes from many sources. So one of the types of surveys that a lot of people are familiar with are political polls, or like public opinion polls in general. And oftentimes you'll see that they'll report something like the error on this survey is plus or minus 3%, 19 times out of 20. And in that case, what they're really reporting on is the margin of random sampling error, which, if you look at this diagram, is one sort of piece of survey error. So that's just the error that comes from the statistical uncertainty that you have because you haven't talked to everyone that you're making conclusions about. There's a lot of other areas that you should be thinking about if you're seeing survey data about how it was collected. So who was actually able to take the survey, like what type of collection method was used. So if there's a systematic bias as to who was included and who wasn't included as part of that, whether or not the way that the survey question was asked actually represents what it's measuring. So you can have leading questions, like, do you think the city's doing a good job? Yes, strongly agree. no, kind of agree. It doesn't give you a very good response. So you want to look at those aspects of it. Whether or not there are any errors in data processing that can happen, just an error in specifying who is included. And a lot of these aspects are a lot more difficult to measure. So they're more of questions that you should be thinking about as the data analyst, about what conclusions you can actually make from the data that you have. So right off the bat, there are some practical considerations with surveys. So the biggest one is whether or not you're going to have a probability or a non-probability sample. So what I mean by that is a probability sample is a sample where every member of the population, I should say population, has a chance of being included in the sample. So when everyone had a landline telephone, you could say, like, if I randomly call 1 in 100 phones, then there's a random chance that any one person could have been called, and they could have been included in the sample. However, this is considered to be the gold standard of research. You have a probability sample, you know who all the people are who are in your population, you know that every single person that you've sampled, every person in the population had what could have conceivably been included in the sample, and then all the statistics that you learn in like Statistics 101 apply to the analysis of your sample, and you can apply sort of your probability to it. Generally speaking, like, it's quite common now to use like what are called non-probability samples, or convenience samples. And these are samples where, say you go to a provider like the NADA or Asking Canadians, and they have some people that are already signed up to take surveys, and then you send your survey to those people, and they do your survey, or you send it out to some people that you know will take the survey, and you just assume that they're kind of similar to the people that you're interested in, and you make your inferences from there. It's very contentious in the survey research community as to whether or not that is even remotely acceptable to do. It's widespreadly practiced in market research in particular. And then there's newer methods that are somewhere in between, where you have like a panel, which is a group of people that you can field the surveys to, who have been recruited through a probability method. So it's like a halfway between. And this happens a lot. So in the Canadian Social Harmony Index survey, which is the data that I'm going to show you today, we used a panel to recruit. We specifically used a Donatus panel to recruit. And essentially the underlying assumption there is that we think that the panelists are similar enough to the overall population of Canada that we can make good inferences on it. And one of the ways that we kind of suspect that this is true is because when we've done, for example, like a political poll to see if this predicts how people actually vote later, it's pretty close. So that would suggest that this assumption's not too far off. Generally, it costs a lot more money to do a probability sample, sometimes like 10 times as much money. So that's often a big consideration as well. So once you've collected your data, and you're looking at your data set, there's a few things that will immediately come up that you need to deal with. And one of the most common ones is missing data. And I wanted to start with this because dealing with missing data is often one of the first steps that you need to deal with when you're looking at survey data. If you want to do subsequent steps, if you have this missing data, you have to decide what to do with it. So there's really 3 main ways that you can have missing data. The first, and the one that is the best case scenario, is if your missing data is just missing completely at random, like there's absolutely no rhyme or reason as to why that data point is missing. Like, it's almost like an act of God, if you will, that person didn't respond to that response, and there's no underlying reason. And in this case, your missing data is in no way changing the distribution of responses. On the flip side of that, you have missing not at random. And in this case, there's a pattern to the missingness. And this is really like a larger problem that as the analytic, you're going to have a very hard time with dealing with at this point, but it's something that you want to look for when you're looking at the survey data. Like, is there this missing not at random problem, which could indicate a larger issue with the data collection process. So maybe someone phrased a problem that was like a question that was really sensitive, and then people that actually did say like, say like you asked someone if they'd committed a crime in the last week, and then all the people that had committed crimes in the last week all say no because they don't want you to find out, then that would be a bad question. And then you would have missing not at random, where there's actually this bias in the way that people are answering the survey question that's distorting how you can sorry, it wouldn't be lying, they're just not responding to that question, which is distorting the actual results of your survey. So this is something that you'd want to look for if there's if there's something to indicate that this is happening. And the last one I mentioned here, which could have been the second one, I guess, is missing at random, where there's a relationship between the missingness and the in the survey and the data and the value that you're measuring. So you might have like a bias where sort of like one demographic, like young people, are more likely to actually answer this question than older people are. But otherwise, it's not, it's still at random, sort of in the, the relationship isn't two directional. So you don't have this like a sort of dependency between them. And then in that case, you can still sort of proceed. It's just with the missing not at random that you have a big problem. In reality, you almost never truly have completely missing completely at random, but a lot of techniques make the assumption that you do. So it needs to be close enough. So I wanted to jump right into what we do with our missing values. So one of the leading techniques to deal with missing data in your data in your data set is to use this method called mice. So there's a lot of methods to deal with missing data. Like one of the simplest ones is you just delete all of the observations where there was missing data for some reason, and then you just have less data, but you have only complete data. That would be complete cases. You could just take the average and make all of the missing ones be the average. You could use the median or the mode or something like that for the same process. And all those works. But then more recently, this mice technique has been really taking off. And I think the reason for that will become quite apparent. It just does very, very well on dealing with this problem of missing data. So it stands for multivariate imputation by chained equations. So basically what you're doing is you're taking all of the other variables in your data set, or some number of the other variables, not usually all of them, in your data set, and you're using that to estimate your missing values. So it generates these things that they call plausible synthetic values. So you're kind of thinking like, if I don't know what the age is of my respondent, can I estimate their age based on the way that they've responded to all of the other questions that I have in my survey or something like that, or some as close to all of the other questions as I can. So technically speaking, the defaults with it, and this is just from the documentation, is they'll use predictive mean matching, which is for the numeric data where it's looking for similar cases and finding other and estimating what that value is based on what other people in the survey responded or in the data set. Other values with similar attributes across other variables look like. It'll use logistic regression for binary data. So it's essentially doing regression on your other values in your survey and then using that to guess what that missing value should have been if you could have only seen it. And then it uses essentially other versions of regression, like ordered regression, when there's more for different data types. General rule is to only impute when you have up to sort of 5% of values missing. Although that said, that's really only a guiding rule. And this is definitely like an area of active research. And I've come across some stuff recently where I've seen people that were doing it on more, or some people that were saying, actually, you can only really do 2%. So it's a little bit of you sort of look into it for your specific case and sort of see what you're personally comfortable with. Probably sounds familiar for a lot of data analysis issues. So I'm going to switch over quickly and show you an example of what this actually looks like if you're going to do it in R, and some of the things that you should just be aware of if you are trying to do this yourself with your own survey data. And I'll talk through a couple more things. Just a big disclaimer is I'm making some massive assumptions in the analysis that we're going to do that you probably shouldn't just assume if you're looking at your own survey data. The big one is I'm ignoring some stratification in the survey design, which is where you change the number of respondents that you take from different subgroups so that you have enough people in them. So I'm ignoring that design effect. And then I'm assuming missing completely at random, which is probably not perfectly valid assumption, but for the purposes today, it makes sense. So just stop sharing and switch screens. Okay, so should be seeing a Rstudio session here. So for this demonstration, I'm using R and the tidyverse of packages. If you're an R user, you'd probably be familiar with. And then this survey package and this survey R package, which is essentially the survey R package, but reskinned to conform with the tidyverse conventions. Thank you, Hadley Wickham. So just setting my directory to my source file location here, and then I'm bringing in this clean data set. Actually, so this has 1,575 observations, and this was part of this survey data that we collected in November, and it was mostly asking Canadians about what their values are and to what extent they feel like they're able to get along with others and want to collaborate and cooperate with others across the country. So I've already cleaned this data set. So, it didn't come in perfectly coded in R, but it is now. And then I have this forward sortation area key with the postal codes, which is just assigning the first digit of your postal code as to what region of the country that comes from. And then I'm using as my baseline, that's for later, I'll be using the census data. So I'll just go pull that in now. It's a gigantic file. Why would I say? So conveniently in R, there's this package called mice that will handle really all of the difficult pieces of the implementation of the mice algorithm. So if we look here, I'm going to start by just making a subset of my data set that I want to use for my imputation. So I just close this here. I have a bunch of different questions. So I have gender, age, education, region, whether or not the person was in a rural area, and then a bunch of these are psychological questions about the respondent's worldview that I care about a lot in this analysis. So I'm going to use those as part of my prediction of what the missing values could have been. And really, the only data in this survey that was missing was non-binary gender data, because the data had to match to the census 2016 census data. So those values had to be essentially we had to use a binary gender category in order to match it to the way that that data was reported in 2016. So those values are missing, and then and we kind of know what, and we know why. And then for age, I've just added some randomly missing ages here artificially, just so that there would be some more missing values in the data set. I see there's some questions. Take a look. Okay. Yeah, there are some tests for missing not at random that you can do. A lot of them have to do with like looking at like exploratory data analysis, looking at this the distribution of your variables, and it's a bit of an it's part art, part science sort of thing. Yeah, I would definitely encourage you to look at that. There's just tons of resources online. And then yeah, mice does work on non-numeric data. So actually, for these ones, we'll be showing mostly non-numeric data. And I'm unfortunately not familiar with the mice forest package, although I have, talking to a friend who's done this in Python, I know there is a mice implementation in Python that you can use, and it's very similar to the one that you're looking at now. Okay, so if we look here, if we remember, like we're like interested in knowing if there's less than 5% of our data is missing. So here I've just looked at the proportion in each category. You can see we have very, very few missing values in the gender category or in the age one. The other ones I know are complete, but normally you would check all of them, but the other columns are complete. So now we're just going to take a quick look at this this mice algorithm. So for this, I'm going to show you. Actually, I'll just run this right now because this takes a minute. It's taking a few minutes. So here, like their documentation is great. Essentially, everything that you could want to control around this this algorithm, you can just specify in the function. The main ones being like what methods you want to use to do the imputation with, and the number of iterations it's going to do through it. Basically, you pass in your data set, and by default, for every column, it will check if that column has any missing values in it, and then will impute what it thinks the missing values are multiple times. So it's doing this process over and over again. So you can see we're on iteration 1, it's going to do this 5 times. It's gone through iteration 2. Now it's going through iteration 3, and it's doing this process a few times, and it will take the one that it'll either take the average value or it will take the most common value that it's predicted as what the imputed value is going to be. So this will just take another minute. Let's see if we have another question. Yeah, I'm not sure about the survey analysis in Python, to be honest. It is actually like a bit of a strength of R, is statistical like survey analysis or anything that is really academically based. One of the areas where R shines quite a bit. Okay, so there we go. So now we have this object here, and it's this essentially this object that comes from the mice package, and this has a whole bunch of information about what actually happened, what the mice algorithm has done. So it's looking at, it'll show you just a whole bunch of things, like what it actually imputed, what method it used. So it used logistic regression to impute the gender, and it used an ordered logistic regression to impute the ages, since those were the variables. And then for all these other ones, it didn't need to because they didn't have any missing values. So we can see that right away, but there's a whole bunch of things in this object. And if this is something that you're interested in, like, I really encourage you to like look at their documentation and explore a whole bunch of diagnostic plots and things like that that the mice package includes with it. Really simply, once you have this MIDS object, you just pass it to this complete function here, and that fills in all of the missing values. So what I've done here is I passed it into this complete function. I've taken my IDs from my original data set and added them back because we lost them during the imputation process. And then I selected just the columns that I'm going to be interested in for later. So do that. And then you can see here, we now don't have any missing data. If you remember from way earlier, we were missing, actually I can show you. Wrong one. Right before, we had this missing value here for this 10th row. And now in the imputed one, it's decided that that person was aged 35 to 54. So then we can use that value in subsequent analysis, or more importantly, in the survey weighting, which is where we'll go with this next. And then a couple next steps on this that we normally include is like maybe checking the accuracy of how well it did on some of these ages that we imputed, where we know what it should have actually gotten. So you can check you can go back and check if you want to sort of artificially construct adding some missing values and seeing if it gets it right. And then checking the distribution of the imputed values versus the sample distribution to sort of see if there's any issues in how the algorithm is making those imputations. Yeah, so I'll check for questions now quickly. The raw survey data from survey forms. Yeah, you can pretty much load in your survey data in whatever format you want. So CSV, Excel files, but you can also load in like JSON. Like this was located as loaded in as a RDS file, which is like native to R. So yeah, there's pretty much whatever you want to import it as. Yes, you can purposely drop the data and see if it fits with the same values. And that's kind of what we did here, where we dropped this. So I could have gone back with some more time and then checked to see if it had actually found the right values before we had dropped them. Okay, so with that, I'm just going to quickly jump back over to my presentation. Okay. So then the next step in the process, so I guess we've briefly covered how to impute missing values if you have missing values in your survey. What I should have mentioned earlier was one of the most common ways that you have missing values is if you have like a prefer not to say, or someone declined to respond to the survey. So if someone was doing a live interview and the person just said, like, I don't want to answer that question, and the person moved on, then you'd have a missing value that way. Or on a web survey, sometimes you have like a prefer or don't know, and you just treat those as missing values and you impute them. There's a whole other set of questions about whether or not that's the right decision for that survey, but those are two sort of common ways that I've seen missing values show up. So then the next thing I'll talk about is weighting. So it's very common, especially with even with probability samples, that the survey sample that you have won't quite match the population that you're interested in. And then there's some things you can do with weights, propensity weighting, to make your survey more accurate to the group that you're actually interested in learning about. So the most common way to do this is a post-stratification technique called weighting. So what post-stratification means is you've already collected your survey results and you want to make sure that your survey looks something like the people that answered your survey are somewhat similar to the people who you want to make inferences about or learn something about. So if you had a sample and you notice that your sample was, and if you're going to sample like people in Calgary, you might want to make sure that about half of them are male and about half of them are female if you thought that was an important part of the representation that you needed for that survey sample. So if you were to go out and say, like, I'm only going to collect 50 responses from men and then 50 responses from women in this case, or say, like, I'm going to only collect half my responses are going to be under 45 and half of them will be over 45 years old, then that would be like pre-stratification, where you've preset that essentially. And then post-stratification is afterwards you say, actually, I want to make sure that these survey responses now look like my population that I'm making estimates about, and I'm going to make some adjustments to the data that I've collected in order to make sure that that's true. So you can only do this within limits, as you can probably imagine, but it's very common. It's almost done by every pollster everywhere. And essentially what happens is you have this idea that you can calculate the inverse probability of the selection to remove the bias. So it's like if you found that you knew that like half the people that you wanted to study were like over the age of 45 and half of them were under the age of 45, and you noticed that 75% of your respondents were actually like under 45, then you would make an adjustment so that after that adjustment, your probabilities were correct essentially. So the raking algorithm iteratively adjusts the weights to match the survey distributions to the known population distribution. In R, this is implemented using the rake function from the survey package. And one of the really nice things about this technique is it only requires you to know what the marginal population answers are. So you don't need to know like how many, if you wanted to weight by province, you only need to know how many people should have been from Ontario and how many should have been from Alberta when you make the adjustments. And then you need to know how many should have been in each age category across the whole board. You don't need to know how many should have been in each category in each region. Which makes it a lot easier to find that population data to adjust to. So, yeah. Question. Yes, we should definitely have a federal census more often. Completely agree. The Calgary census is wonderful for this. And we are in like the worst census year because we're still using 2016 and they're currently fielding. If you're trying to do estimates on like the southern outskirts or like the northern outskirts of Calgary, it's really bad actually. So on that note, I'll show you an example of how this actually works in R, and this one will use population data from Stats Canada. So this is the population data by forward sortation area, which is the first 3 digits of your postal code. So if you ever see a question on a survey asking for the first 3 digits of your postal code, this is probably why they're asking for it, so that they can then use the census data to adjust your response. Okay. So hopefully we're back in our studio session. We'll go down here. So to start, I've cleaned up the census file a bit. So basically dropped out levels that weren't the ones that I was interested in. So I was only interested in a certain geo level. And then renamed these columns because no one wants to retype that. And then converted them to numbers here. And then extracted the region code. And then I used this key that I had, which was way up here, to determine from the first letter of the postal code which region of Canada they're from. So if I run this, that takes a little while. There's like what 370,000 rows in this data set. You now get something like this, where you have the region. This is Atlantic Canada. For postal code starts with an A there. And then here you have the attribute, and then the total, and then the male and the female columns. So from this, we're only interested in a certain one of these categories. Something I'll say is there's like these profile IDs. If you are looking at the census data, like they have this huge key that you can get, and you can find the profile IDs that correspond to the different values that you might be interested in. It's a much faster way of getting out the data that you're looking for. But then to start with, so what I need to do is I need to make these tables. I'll show you what the tables are and then show you how I made them, where I have the attribute that I'm interested in and the frequency. So when I first learned how to do this, I found this infuriatingly difficult to figure out what it was actually asking for as an input into the algorithm. But you basically need this. So you need the attribute named the actual attribute as it matches in your survey data set. And then you need the frequency column, which has the number that you would expect to have in your survey, like if they matched perfectly to the population that you're interested in. So in this case, what I've done is I've selected the male and female columns. I've taken the overall population for that region, transformed this, like pivot it into a longer format, dropped the missing values, summed them up, and then taken the frequency and then multiplied that frequency by the number of observations that were in the survey. So that's the adjustment. So essentially you have the proportion that should have been in each category, and then you multiply that by the total number of observations in the survey. So this should add up to 575, which it does. So we do the same thing for region. So we get like how many people we'd expect to be in each area. Then education. It's always surprising, I think, like the percentage that where it's a high school, always a very large number. It's always a very small number in the survey sample. So it's usually a big area that you need to make an adjustment for. And then age. I think I saw. Age, and then this is if they were in a rural postal code or not a rural postal code. So rural postal code is if your postal code second digit is 0. And then this is just a quick check, like a sanity check essentially. Are the levels of the different factors all the same? So these should all just say true, and they do. But it's a good check just before you go into this. Then so with the survey package, it has this idea called like a survey design. And a survey design is essentially an object in R that holds information about how your survey was fielded. So it will say like, these are the probabilities of someone being included. These were the strata that we used if you have a stratified survey design. And it keeps all of these things, it stores all these things, and then you can use that information to make estimates about, to learn things essentially about the, to use them to make predictions or in models that you use based on your survey data later. So this is going to turn them into this, and I'm just choosing, I'd use this one. And I get this warning which said like no weights or probabilities are supplied. So it's assuming there was an equal probability that any one of the people that I was selected would have been included, which is wrong. So that's what we're going to fix. So you can see it has this class survey design, which is what we want. So then this is this function rake I mentioned earlier. So this takes these arguments, which is the survey design. So that's what this is. So this is like, and then the sample margins. And the sample margins are the names of the columns that you want to use to adjust your survey. And then they just take this function notation from R. And then the population margins are these data frames that you need in order to adjust to. So what the targets are that it should be matching to. These are the distributions that you want the end result to look like. So if I run this, I get an independent sampling design with replacement, and it essentially says that it has these attributes. So then immediately the next step is question. I can briefly show you how to visualize some of this right at the end if we have time. So if we look here, we can see this is the maximum weight is 6.6-ish, and the minimum weight is 0.149. And then if we look at this in a plot here, we can kind of see that this is the distribution of my weights. And I'll just say, like, this is pretty bad. Generally, like, the sort of accepted rule, at least that I've been taught, is you don't want weights of more than about 3.3. And just like conceptually, think about like what this is doing. It means that like one person's response from this could be worth 6.6 times more than the average person's response in the survey. And actually it could be worth way more than this person that's only like 0.15 weighted, because they're so like underrepresented in the sample that this person needs to be really important in the weight in order to get that population margin that I specified. So personally, like, I wouldn't like this. So to adjust for that, I can just like, okay, maybe I'll just drop the rural piece. So you're going to drop the rural, and now we get 3.9 and 0.17, which is like, okay, it's not the best, but we're getting there. And you can see now our distribution looks a little bit better. It's still a bit skewed, but worse things have happened. So then finally, there's this last measure that you can use, which is just this trim weight function, which I would recommend generally, where you can set that you say, like, I only want the weights to ever go up to 3.3 or down to 0.3. And that just makes a final adjustment to the survey weights. And then you can see it trimmed them, and it sort of adjusted everything in a little bit to bring it sort of to stop like one opinion or one response from skewing the outcome too much. Yeah, so it does weighting across all of those different fields. So it's an iterative process. Like it does this sort of it keeps adjusting them a little bit until it's like a numerical process until it gets close enough to the population margins, basically bang on the population margins. And that's how you can get that one person. So it'll say like, we don't have any people that match the category of like over 55, rural, male, and in Atlantic Canada. And then so it finds one person that matches that and makes them have a ton of points. Have a really high weight until it matches. And then finally, you can see here. So then we get these weights. So we get this this sample design with weights, and it has some weights that you can see. So each observation gets weighted something. Actually, So each observation is getting assigned some weight to adjust for how much more or less likely they should have been to be included in the survey versus what we actually saw. So one last thing, just because of the question, what you can do with this is you can say like group by age, summarize. You can use these survey functions. So this survey, our package has a bunch of survey functions in it, and like survey total. And then it will calculate those confidence intervals around your survey statistics. So then this can be used. Basically, you could either export this data and then bring it into something like Tableau or another like data visualization software, or of course, because these are data frames, if you're an R user, it can now basically go into like ggplot or Lattice or whatever your favorite plotting software is, and yeah, you're good to go. So yeah, that is my presentation. So any questions?
That's really fascinating to see that, Cam. It's kind of like going into the sausage factory to see how the sausage is actually made. So I'm curious in terms of when someone like yourself or others, do analysis of surveys and then release results. In terms of the sort of disclaimers or notes or somewhere, do you provide some of the techniques or steps that were taken typically, so that somebody knows what's going on behind the scenes?
It's contentious. You can imagine.
Yeah.
Yeah, like generally, like if you see anything in the press that's reporting like that they have a margin of error plus or minus this, they're typically using this raking process to do the weighting. It's by far the most common one, and it's used by like very reputable survey research groups like Pew Research. This is their staple technique for it. In terms of the survey error, yeah, it's a big debate, because it definitely used to be the case when, again, like everyone had a landline phone, that was really the gold standard, which you called everyone, and then you said, well, almost everyone has a phone, and basically anyone could pick up the phone. So now we've satisfied that we're a perfect like probability sample. But then there's probably a lot of people on this call that would sort of relate that if you see a call now from an unknown number, you're just not answering it no matter what. So that's been hard. And then some companies are doing some like honestly really cool work with web sampling. That's like quite innovative. But then there's a question, how do you say for sure that someone could have been included in the survey? So can you make those inferences? And those are the bigger questions, and they're not reported on at all, of course.
No. There's a few other questions in the chat there. If you want to field those, or
yeah. How good is the weighting process if you've outliers? Yeah, I mean, there was like a somewhat famous case that there was like a single respondent in a state poll in the United States that like swung the whole entire poll 3% because they matched like this perfect demographic box that was really hard to field. And that's bad. Just generally, like logically, that just seems like a bad thing. So part of it is like actually just looking at those and going like, am I okay with someone having like a weight of 10? Like probably not. Or how much would this actually affect my results if this person exists? Because generally you're trying to find population averages more than you're trying to find like these outlier opinions. News almost never mentions. Yeah, news almost never mentions the error rate, except for the small print. Yeah, it's true. And like, I mean, I think one of the, like, if there's like one big takeaway, I would say is like, if you look, if we go back up here, like, you know, what do you call it? The actual measurement in the sample size, like the sampling error, is a small piece of the total amount of error that you end up with in your survey. So even then, it's kind of hard. So you want to sort of look at the track record. The last thing I'd say about that is maybe political polling gets a bad rap, but in its defense, it's one of the only times that you can actually measure whether or not the survey was right or wrong. So in a lot of cases, you'll just never know if the survey got the true, like the truth, like the ground truth correct.
So is there anything like a code of ethics or something like that for people that are involved with analysis of surveys and polls and that sort of thing?
Yeah, for sure. I mean, a lot of my colleagues are members of APOR, which is a sort of academic and industry association across North America of essentially survey science researchers and market researchers and pollsters that share best practices across essentially a very large listserv. And they maintain professional standards that their members are to adhere to, and it's and a lot of those include some of these, like, I think, really good points about declaring what assumptions you've made and how you're doing your adjustment and things like that. I don't have a example of a full dashboard like immediately. Generally, the biggest thing is you would typically plot like an error bar around that point estimate that you have in addition to it. Depending on who you talk to, there's some like data visualization guidelines that some people follow and some people ignore or find them confusing. So that's also like, how do you visualize uncertainty is a large and unanswered question. It's quite interesting. But generally speaking, for your dashboard, you can visualize them the same way that you would like a general like results dashboard for any sort of other type of data, just accounting for the uncertainty in the estimate.
Okay, maybe just a couple more questions and we'll kind of wrap things up there.
Yeah, sounds good. So then last question maybe is on survey data where collection of data is questionable due to perform any substitution in data. Yeah, I mean, it's a good question. Like, if the survey data, some ways I think like the survey data is what it is. If it's so poorly collected that it's not telling you anything useful, then it's not really data in that sense. All it is data about those people that participated in that survey. That kind of answers your question. You can do more. You can sort of distort it more, or even just feed it into feed your data into like a machine learning model at the sort of the most highly processed end of it, and try to just use it as signal to predict whatever you're interested in predicting in. But yeah, you can save a lot of time with design, and the best survey researchers that I've ever had the privilege of working with just are amazing at getting the right people into the survey. They're just incredible at it. Mm-hmm. And then plotting self-reported opinions on a 1 to 10 scale. Oh, yeah, on the like net promoter score stuff. I mean, the net promoter score is a nice framework for dealing with that. If you're not familiar with it, it's like anything 6 and under is basically bad. 7 and 8 is okay, and then 9 and 10 is good, and then you just average those and you get a score off of it. HR folks love it, like absolutely love it. Customer experience people like live by it too. It seems to do fairly well. Yeah, I mean, it's a great question. I don't feel like I have the answer to that, but I can say anecdotally that there is not nearly as big of a difference from a 2 to 3 as a 2 to a 4 as there is from an 8 to a 10. There's a way bigger difference. So treat them accordingly.
Great. Well, thanks, Cam, so much for your insights and sharing your knowledge with us. So, as I said, we have the recording up and a copy of your presentation, and then folks, I think, can probably reach out to you if they have a burning question sometime in the future. And I know that you're working with some of our Data for Good volunteers to do some visualization of the survey data, the social harmony data. So that's going to be really interesting when that comes through.
Yeah, thank you. And I'll just throw out there, if anyone is interested in just want some of the code, just send me an email. I'm happy to share some of the scripts as well.
Okay. All right. All right. Well, we'll wrap it up for this evening. Thanks everybody for joining us. Tune in next time, the fourth Thursday of the month, for our meetups and our various projects and other datathons that are going on in the future. So take care, stay safe, and we'll see you next month. Bye now.